Welcome to our channel Sankalp Study Success. In this video, we are going to learn about equivalence of Melay machine and Melay machine. So here, first let us know how to convert Melay machine to Melay machine and also Melay machine to Melay machine as well. Now, the first one is conversion of Melay machine to Melay machine. So here we know what is Melay machine and what is Melay machine. If you see the previous lectures, then you will be knowing what is Melay machine and Melay machine. So here let m is equals to, it is a 6-tuple notation where it says a Melay machine, and then if there is a Melay machine, then there will be an equivalent Melay machine for Melay machine. So this is Melay machine and it is represented by m dash. So here number of states are same in both the machines, input symbols and also output alphabet, input alphabet, transition function, but here lambda and here lambda dash, both are different in Melay machine as well as in Melay machine. So now how to know what is lambda dash? So from this formula, lambda dash of q comma a, that means this is the present state and this is the present input symbol. So by using this formula you can find out what is lambda dash. That means lambda dash of q comma a is equals to lambda of transition function of q comma a. That means what? Now let us see here, the initial state in Melay machine as well as in the Melay machine are same. There is no much difference here. So now let us solve a problem by converting Melay machine to Melay machine. So here convert the following Melay to equivalent Melay machine. So here Q0 and Q1 are nothing but the set of states. A and B are the input symbols, that means it is input alphabet. 0, 1 are the output symbols, and this is the transition function, and it is lambda, which is nothing but the output function, and Q0 is the initial state. See, here we are also having the transitions and also the lambda, which is nothing but 0, 1, which is already given here, which is 0 and 1. So now we need to find out lambda dash. Because each and everything which is m dash is equals to, let us consider m dash is equals to q sigma delta, which is nothing but the output alphabet, transition function, lambda and q0. See, lambda dash. Here each and everything which is present in Melay machine is also same as in Melay machine, but the lambda and the lambda dash are different. So we need to find what is lambda dash. So here the formula of lambda dash, as we all know, lambda dash of q comma a is equal to lambda of transition function of q comma a. So by using this formula, we are going to find out what is lambda dash. Here, first one is nothing but from here we are going to start, because this is the formula. Here lambda dash of, we are having our present state as Q0 and A is the input symbol. So Q0 comma A, which is nothing but we are starting from the initial state. So it becomes lambda of transition function of Q0 comma A. So here transition function of Q0 comma A is nothing but Q0, right? So lambda of Q0. See, what is lambda of Q0? See, Q0, lambda of Q0, which is nothing but 0 here. So that is equal to 0. So in this way, we are going to apply the formula for each and every state by applying each and every input symbol. So that means here we are done with applying input symbol A to Q0. Now let us apply B to Q0. So lambda dash of Q0 comma B, which is equals to lambda of transition function of Q0 comma B. So lambda of, what is transition function of Q0 comma B, which is nothing but Q1, and lambda of Q1 is given as, see, lambda of Q1 it is given as 1. So let us write 1 here. So that means what? Here we are finding the output functions for Q0 and Q1 by applying the input symbols A and B. Now this is nothing but 1. Now let us also find out the lambda dash for Q1. That is lambda dash of Q1 comma A. So it becomes lambda of transition function of q1 comma a. Transition function of q1 comma a is nothing but q0. So lambda of q0, which is equals to lambda of q0 is nothing but 0. So which is equal to 0. Now let us find lambda dash of q1 comma b. So lambda dash of q1 comma b is equals to lambda of transition function of q1 comma b, which is equals to lambda of q1 comma b. Transition function is nothing but q1. So lambda of q1, which is nothing but 1 here. So that is equals to 1. That means till now we have found the lambda dash by applying each and every input symbol to each and every state. Now we are left with no states, right? q1 and q0 and q1 are the states we have. So we have applied q1 for q0 and also for q1. Lambda dash of q0 and q1 is already found. Now what we need to do, we have to draw the transition table for the Melay machine. This is the transition table for Melay, right? Now we have to draw the transition table for Melay. In case if you draw the transition table for Melay machine, then you will get the transition diagram of Melay machine, right? Now let us draw the transition table for Melay. This is for Melay. For Melay machine, if you remember, the transition table will be, first of all, it is a transition function. Then by applying input A and also by applying input B. Then we will be having the next state and also the output for it, right? Here also next state and also the output. So now, what is the transition function? We are having only two states, Q0 and Q1, right? So Q0 and Q1. Now we have already seen that transition function. See here, transition function of Melay machine and Melay machine is same. So all these values will be same. Transition function of Q0 to A, Q0 to B, each and everything will be same, right? So let us write the same values here. Q0, Q1, Q0 and Q1, right? So same values, but the each and every output is different because it is lambda dash of q0 with a. So we got lambda dash of q0 with a as 0, lambda dash of q0 with b as 1. So here by applying input a for q0, then we'll get the output as 0 and here we got 1. In the same way, let us also check for applying A and B to Q1, then we are getting as 0 and 1. See here, 0 and 1. So this is nothing but the transition table, right? So this is the transition table for Melay machine, right? Yes. So from the transition table, we can easily draw the transition diagram for Melay machine. So how do we draw the transition diagram? Now let us see. Let us draw the table completely and then we'll see how to draw the transition diagram. So now the transition diagram consists of only two states, right? Q0 as well as Q1. And also for Melay machine and Melay machine, Q0 is nothing but the initial state. So let us consider this as the initial state. Q0 and Q1. Now see here. By applying input symbol A, Q0 it goes to again Q0 only. That means what? We are having a self loop on Q0 by applying A. So then if you apply A, what is the output here? 0. So this is nothing but the first transition. Then from Q0, if you apply B, then it goes to Q1. So that means by applying B, it goes to Q1, but the output is 1 here. So output is 1. Then Q1, if you apply input symbol A, then it goes to Q0 again. That means it comes back by applying input symbol A. But the output is nothing but 0 here, right? Then now applying input symbol B to Q1, it goes to the same state Q1, which is B. By output is 1. So in this way, we are going to draw the Melay machine for the given equivalent Melay machine, right? So what is the first thing we do here? Here each and for the Melay machine, we will be having an equivalent Melay machine and all the it is a 6-tuple notation, right? So all the tuples are same except lambda, which is nothing but the output function. So we need to find out the lambda dash in order to know the Melay machine. So by applying this formula, you can easily find what is lambda dash for each and every input symbol by applying each and every state by applying each and every input symbol. So then you need to draw the transition table for Melay machine. Then we are going to draw the equivalent transition diagram. So in this way we are going to find Melay machine for the given equivalent Murray machine. Now let us solve one more problem, which is convert the following Murray to equivalent Melay machine. So here directly it is given the transition table. Okay, till now we were given with the number as the 6-tuple notation, but here it is directly given with the transition table. So now the first thing we are going to do is we have to find out the lambda dash of q naught with 0, which is equals to lambda of transition function of q naught comma 0. Then what is the transition function of q naught comma 0, which is nothing but q3. So lambda of q3. Lambda of q3, the output is 0. So in this way we are going to find for each and every state. That means here we are having 4 states. So for 4 states we are going to find it by applying both the input symbols 0 and 1. Now we are done with 0, so let us apply 1. That is lambda dash of q naught comma 1 is equals to lambda of transition function of q naught comma 1, which is nothing but transition function of q naught comma 1 is nothing but q1. So lambda of q1 is nothing but 1. So now let us go to the next state, that is q1 comma 0. Then what is the transition function of q1 comma 0 here, which is nothing but q1 again. So lambda of q1, which is equals to 1. Now lambda dash of q1 comma 1. What is the transition function of q1 comma 1, which is nothing but q2. See here, q1 comma 1, which is nothing but q2. So which is equals to lambda of q2. Lambda of q2 is again 0. Here lambda of q2, lambda is nothing but the output, right? So here you can consider it as lambda. So we are getting the output as 0. Now let us go to the next state, lambda dash of q2 comma 0, which is equals to transition function of lambda of q2 comma 0. Sorry, it is lambda of transition function, right? So here let us have a small change, which is nothing but lambda of transition function of q2 comma 0, which is equals to lambda of what is q2 comma 0, which is nothing but again q2. So lambda of q2 is nothing but 0. So now let us apply the input symbol 1 to q2. Then it becomes lambda of transition function of q2 comma 1. What is q2 comma 1, which is nothing but q3. So lambda of q3. So lambda of q3 is again 0, right? Here it is 0. So now let us go to the last state, q3 comma 0. Then it becomes lambda of transition function of q3 comma 0, which is nothing but q3 comma 0 is again q3. So lambda of q3 is again 0. So now the last thing is lambda dash of q3 comma 1. So what is lambda of transition function of q3 comma 1? So q3 comma 1 is nothing but q naught. So lambda of q naught, which is nothing but it is equals to 0. See here, lambda of q naught is 0. So in this way we are going to find for each and every state by applying each and every input symbol. Now let us draw the transition diagram for the given Murray machine. So here transition table, first of all, for Melay machine, right? It is for Melay machine. So for Melay machine, what will be the transition table? It will be transition function, then by applying input 0, the next state and the output, and also by applying input symbol 1, by applying next state and the output. But here we are having 4 states, q0, which is the initial state, q1, q2 and then q3. So we are having the 4 states. So Q0, by applying Q0, what will be the next state here? Q3, all these transitions are as it is, right? Because there is no change in the transition function. So let us write as it is. Q3, Q1, Q2 and Q3. And here also we are having the same thing, which is nothing but Q1, Q2, Q3 and Q0. But here what are the output? That means lambda dash. Till now we got lambda dash of Q0 0 is 0 and here it is 1. Then it is 1, 0. You have to note down all the values which you got in the lambda dash till now. So we have all these values. Now we have to draw the transition diagram for this table. That means we are having 4 states. Q0, which is the initial state. By applying 0 to Q0, then it goes to Q3. Let us draw it here. By applying up 0, it goes to Q3. Output is also 0 here. So now, by applying 1, it goes to Q1. And the output is 1, right? By applying 1, it goes to Q1 and the output is 1. Here, for Q1, if you apply 0, it again goes to the same state, which is nothing but the self loop 0, but the output is 1. And then by applying 1, it goes to Q2. By applying 1, it goes to Q2 and the output is 0. So from Q2, if you apply 0, it goes to the same state 0, but the output is also 0. Now, by applying 1 to Q2, then it goes to Q3. That means you have to draw in this way. You can draw in any diagram is correct, but the transitions should be correct. Okay, if you can draw it by taking it horizontally, vertically, but the transitions should be correct. So by applying input 1, we are getting the output as 0. So for Q3, if you apply 0, it goes to the same state, but the output is also 0. Then by applying 1, it goes to Q0. Then the output is 0. So this is the final transition diagram for the Melay machine for the given equivalent Melay machine. In this way, we are going to convert Melay machine to Melay machine. Now, we should also know how to convert Melay machine to Melay machine, right? If the given question is in Melay machine, then how do you convert it into Melay? So now, let us see this conversion where conversion of Melay to Melay. That means here M will be considered as Melay and M dash will be considered as Melay. So here, what is the difference between both the states? Both the machines, right? So here we are having Q. Here, but we are having Q cross delta. That means what? Q cross delta is our set of states. And here the input alphabet, output alphabet are one and the same. Here transition state, that means for transition function and the output function both will vary. So now let us see what is the transition function and also what is the lambda dash, that means output function. Here the transition function, the output function formulas are given to us, which are transition dash of q comma b comma a, which is equals to transition function of q comma a comma lambda of q comma a. So now let us see what are these. Now lambda dash of q comma b is b itself. That means now if you solve a problem, then you will come to know how to find out the transition function dash and also how to find out the lambda dash. So now let us solve one problem where you need to convert this Melay machine to equivalent Melay machine. So first let us draw the transition table for the given Melay machine. How do you draw the transition table? By taking the present state, then by applying input 0 and applying input 1, right? The next state and the output should be found. Here also we are going to find the next state and the output. Here our present state, we are having only two states, which is the initial state Q0 and also Q1. So by applying 0 to Q0, then you will go to this Q0 only, but you are getting the output as A. Then by applying 1, then it goes to Q1 and the output is B. Then for Q1, if you apply 0, then it goes to Q1, but the output is B. Here if you apply 1, then it goes to Q0 with an output of A. So here this is the equivalent transition table for the given transition diagram, that is for Melay machine. Now we are going to convert this into Murray machine. So what is the first step which we have? Q dash. Q dash is nothing but Q cross delta, right? What is Q cross delta? Q is nothing but Q0 and Q1, the set of states which are present in Melay machine. So delta is nothing but A and B, right? Because it is nothing but the output alphabet, right? Which is equals to, how do we take Q0 with A, which is the one state, Q0 with B, which is another state, again with the help of Q1 comma A, and then it is Q1 comma B. So these are the set of states which we will have in the equivalent Murray machine. So here what we are going to see is, for Q0, here the initial state in the Melay machine is Q0. So for Murray machine, the equivalent initial state will become Q0 comma A or Q0 comma B. Any one of these states may become the initial state in the Murray machine. So here now let us find what is lambda dash and the transition function dash. Now let us take lambda dash of Q0 comma A. We have to find for each and every state. These are the states present in the Murray machine, right? For each and every state you are going to find what is lambda dash and what is transition function dash. So lambda dash of Q0 comma A will become A. Why? Because from this above formula Q comma B is nothing but B. So in the same way Q0 comma A is again nothing but A. So this is the lambda dash. Now transition function dash of Q0 comma A by applying input symbol 0. That means this is the state. For this state we are applying input symbol 0. Then what will be the next state? That means what is the formula we have? Transition function of Q0 comma 0 comma lambda of Q0 comma 0. This is the formula which we have. So what is Q0 comma 0? Q0 comma 0, it again goes to Q0 only. So here we are going to Q0. Then what is the lambda of Q0 comma 0? Lambda is nothing but the output, which is equals to A. Q0 comma A. So by applying 0 to Q0 comma A, it again goes to Q0 comma A. This is the transition, which is a move from Q0 comma A state by applying an input 0. So in the same way we are going to find the transition function dash by applying the input symbol 1 to the same state. So transition function dash of Q0 comma A by applying the input symbol 1. So now according to the formula, transition function of Q0 comma 1 comma lambda of Q0 comma 1. Here transition function of Q0 comma 1, that means by applying Q1 to Q0 we will get Q1 comma, what is the output if you apply 1 to the Q0, which is nothing but B. So we got another state by applying 1 to Q0 comma A, that is nothing but Q1 comma B. So now we are done with Q0 comma A. Now let us find what is lambda dash of Q0 comma B. Lambda dash of Q0 comma B is nothing but B, right? Because whatever is there here, then that is the answer, right? From the given formula. Now we are going to find Q0 comma B, transition function of Q0 comma B, that is transition dash of Q0 comma B comma 0. That means you are applying 0. Then from the formula, transition function of Q0 comma B comma lambda of Q0 comma B. Here transition function of Q0 comma, which is not B, right, which is 0 actually. So now let us change Q0 comma 0 and Q0 comma 0. Then we are going to get the transition function of Q0 comma 0 is nothing but Q0 and Q0 comma 1 is nothing but Q1. But here we need to also find the output, which is nothing but A, Q0 comma A. That means the transition dash of Q0 comma 0, Q0 comma B, if you apply 0, then you will get Q0 comma A. Now by applying 1, then what does it become? Q0 comma B. By applying 1, from the formula we are going to write Q0 comma 1 comma lambda of Q0 comma 1 is nothing but Q1 and the output is B. So Q1 comma B. Now let us find the lambda dash of Q1 comma A. Right, this is the next state which we have. So we will get the same answer as A. Now we are going to find the transition function dash of Q0 comma A by applying 0 as well as by applying 1. So from the formula we will get Q0 comma 0 comma lambda of Q0 comma 0. Then here we are going to get, by applying Q0 comma 0, here we are going to get, for Q0 comma 0 it is Q0 and the output is A. So which is nothing but Q0 comma A. Here, sorry, it is not Q0, right, which is Q1 actually. So this is nothing but Q1. Q1 comma A, which is Q1 comma 0 and Q1 comma 0. So for Q1 comma 0, which is nothing but Q1 and Q1, and the output is nothing but B here. So Q1 comma B. Now by applying transition dash of Q1 comma A, we are going to apply 1 here. Then it becomes transition of Q1 comma 1 comma lambda of Q1 comma 1. Then transition function of Q1 comma 1 is nothing but Q0 and the output is A. So Q0 comma A. Now we are going to find the lambda dash of the last state, which is Q1 comma B, which is equals to B. Now we are going to find out the transition dash of Q1 comma B by applying input symbol 0. Then from the formula, transition of Q1 comma 0 comma lambda of Q1 comma 0. Transition function of Q1 comma 0 is nothing but Q1 and the output is B. So it is nothing but Q1 comma B. Then transition function dash of Q1 comma B comma 1. Then here we are going to get transition of Q1 comma 1 comma lambda of Q1 comma 1, which is equals to Q1 comma 1 is nothing but Q0 and the output is A. So Q0 comma A is the output. Now we are going to draw the transition table for the given Melay machine. That means we are converting from Melay to Melay, right? So we have already drawn the transition table for Melay machine. Now we are going to draw the transition table for Melay. This is for Melay. So for Melay machine, there are only 3, right? 3 columns: present state, by applying 0 and by applying 1. Also we are going to have one more, which is nothing but lambda, right? So present state, there are 4 states which we got, right? Q0A, Q0B, Q1A and Q1B and Q1B. So by applying 0, Q0A, we got Q0A, and by applying 1 we got Q1B, right? Then for Q0B, by applying 0 you got Q0A. Then here for 1 you got Q1B. Then for Q1A we got Q1B, and then here we got Q0A. Then for Q1B, by applying 0 we got Q1B, and then we got Q0A. So, and also we have got the lambda, right, which is nothing but A, B and A and B. So this is the transition table for Melay machine. Now we are going to draw the transition diagram. Here Q0 comma A is the initial state which we consider, because Q0 comma A or Q0 comma B, you can consider any one as the initial state. So we are considering Q0 comma A. By applying 0, it goes to Q0 comma A, right? But the output is nothing but 1, right? By applying 0, you got Q0 comma A. Now by applying 1, it goes to Q1 comma B. Here by applying 1, it goes to Q1 comma B. Now for Q0 comma B, if you apply 0, it moves to Q0 comma A. Then it like this, let us consider Q0 comma B. By applying 0, it is going to Q0 comma A. Now by applying 1, it is moving to Q1 comma B. That means what here? Like this, we are going to apply 1 here. Now for Q1 comma A, that means let us take one more state, Q1 comma A. So for this state, if you apply 0, it is moving to Q1 comma B. And if you apply 1, it is moving to Q0 comma A. So let us consider in this way. Now for Q1 comma B, if you apply 0, it is moving to the same state, which is Q1 comma B. But if you apply 1, it is going to Q0 comma A. That means this is the equivalent transition diagram for the Melay machine for the given Melay machine. So in this way, you are going to find Melay machine to Melay machine. That means conversion of Melay to Melay. So in this conversion, the extra thing which we add is we are also going to find out the transition function dash. But previously, in converting Melay machine to Melay machine, we are going to just find out the lambda dash. So this is the difference between conversion of Melay to Melay and Melay to Melay. Now let us see some of the applications of finite automata. Here, applications of finite automata are, the first one is it is used in the lexical analysis of a compiler. This is the main and the most important application which is generally used for the lexical analysis of a compiler. And also it is used for recognizing the pattern using regular expressions. So this regular expressions we are going to see in unit 2. So in the unit 2, we are going to see what is a regular expression and we are also going to solve the problem. So it is this finite automata, it is used in the regular expressions as well. Then for designing the combination and sequential circuits using Melay and Melay machines, and it is also used in the text editors. In the text editors, we are going to use finite automata. Then for implementation of spell checkers, that means what is the spelling which is given is correct or not. That means whether it is true or false. It is going to check by the finite automata, and it is also used as a model for learning and decision making, whether it is true or false. So in that way, we are going to use finite automata, and also can parse text to extract information and structure data. So in this way, these are some of the applications of finite automata, where these applications may be you can expect for 2 or 3 marks questions, because as it is our 18 syllabus, we are going to have 2 marks and 3 marks questions. So you can expect this for 2 marks. And also from this chapter, equivalence of Melay to Melay and Melay to Melay are the most important, and you can surely expect for 10 marks answers in the external exams. So thank you for watching the video.